So welcome back to the second half of class 10, right? Class number 10 of emerging technologies for lifetime learning. Right. So today we are going to talk about, this morning, we talked about this cryptography and cybersecurity. Today, for the rest of the lecture, anybody knows where Peanut is? Okay, Peanut's gone. Okay, anyway. Where's Peanut? Where's Peanut? Okay, where's everyone? Hello? Okay. This is terrible. That's why I never want to teach Zoom again. So next week will come, I guess, seeing how this is today, we shouldn't have a Zoom class anymore. So next week we'll go back to in class, I guess, because this is terrible. Everybody's gone. It's not good. Okay, so Panchita, all these people are on print screen, all these people are disappearing. So, okay. 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 Soโอเคครับงั้นเดี๋ยวเรามาเริ่มกันใหม่แล้วกัน Okay, sit down. Right. Okay. Welcome to the second half of class 10 of emerging technology for lifelong learning. In the first half, we talked about cryptography and cybersecurity. Okay, and see how it can be used to demonstrate that, you know, for technology to emerge, you have to have confluence of events. Basically, we talk about this equation of demand, supply, and so forth, right? So with regards to the cryptography, right? The demand here is a system, right? What's a demand? Demand is the internet, right? You want to be able to share, exchange secret over the internet. So let's say up to, including World War II, the military can keep secret. Okay, but now you want everybody wants to, the modern system is everybody wants to be able to share and send secret over the internet. Okay, the science and technology, well, that's actually been some of it goes all the way back to ancient time. That's encryption. But the technology, the invention that became that what we need this is what we mentioned. Oops, sorry. E.g. Diffie-Hellman key exchange protocol, RSA, or elliptic curve public key cryptography. So need that, and then you need the internet, and now we have cryptography being something that you can do. Okay, you can do, right? So we'll talk about that. Now, the second half, which is a smaller half, maybe a third of this class, I'm going to talk about this technology, okay? And, you know, see that behind the hype, what can we ask about? In particular, what I'm interested in this thing is what can it deliver? What kind of what kind of solution emerging technology can deliver? And how has society evolved with it? This piece of technology, I'm going to lump it under these three things, okay? So let's go to class note. GPS, satellite imagery, okay, so it's imaging. So satellite imaging, maybe easier to say, and GIS. Okay. Now, I'm going to give something that's, well, you already know this, right? You know this. So Google Map, that's no brainer, right? You need GPS to do Google Map. And then on top of that, Google Map, then you keep adding information. That's GIS, right? So you Google Map, you can do, can position, can find your position live, okay? Find your current position, okay? So that's the GPS, right? But on top of GPS, you have information system, okay? Superimpose on street map, okay? Not only that, you can find superimpose on street map along with other pin location, right? So not only can you find current position thanks to GPS, right? You have GIS, which is an information that is like a database, but it's database of street maps, right? Along with other pin location. So it doesn't just keep streets, it keeps location of gas station. So you can run out of a petrol station, a restaurant, shopping center, I don't know. Okay, all kind of stuff. Your friend's address, your home address, your work address. You can keep all this. Plus, what? Algorithm to what? Find shortest or fastest route from A to B. Okay? Yeah. And not only that, fastest route here is not in terms of distance, but in terms of traffic value, taking into account current traffic. So many things has to happen, right? So you have to know position on the street maps. Okay. And location. And then fastest route. Okay. So this, you don't need to, I don't need to tell you about this, right? You don't need satellite imaging because you don't need to, when you go to Google Map, you don't need to see a real picture, but you certainly can. So let's go to Google Map, right? So you just, basically that's it. Simple, right? So I am somewhere, well, if you turn this on in the login, you say, I'm here, I'm there, blah, blah, blah. Okay. Okay, I'll come back to that. Fine. Okay. So you have this. So let's say GPS plus GIS. Okay. Now, so I'm just giving you some nice picture, but you can certainly add picture. All right, you can add picture. Okay, so this is satellite imaging, but that's kind of like fancy, right? It's not really adding much to your travel. It just looks nice. Okay, so satellite imaging. Okay, so you can do that. Okay, but that's you can do a lot already with this. Now today, I'm going to give you an example of what happens. You actually need this. Okay, right. So let's go to the notion of today's class, today's second class. Internet sleuth. Okay, so this is my theme, Internet sleuth. You guys know what this means, right? Anybody? Anybody? Gosh, you guys are all dead today. Oh, sorry, that's anybody alive out there? I'm just gonna assume. Okay, what's internet sleuth? Internet sleuth. Okay, so this is sort of like, oh, like a web sleuth. That's a good word. Okay, so it's sort of like people who are, well, this is a particular website, so I don't want that. So internet sleuth, it's sort of like an internet community coming together to solve crime. Okay, so let's say internet community coming together, pitching in, let's call it pitching in, solve crime. Okay, pitching in to solve crime. Well, if you enlarge the concept a little bit, instead of solve crime, okay, let's go from solving crime to defogging the fog of war. Okay, right, and this is where you have what's happening right now. Yeah, what's happening. So let's say let's take Ukraine. Okay, crisis, conflict, crisis as case study. Okay, say case study, right? So what's the fog of war? Okay, what's the fog of war? Fog of war is, let's say, well, how many, let's say how many ships, okay? How many ships are ready to attack Mariupol or Odessa, let's say, okay? Or how many ships been sunk, okay? Or how many tanks been hit with javelin. Now, all this, okay, all this, the military people are doing it, right? So you have satellite people. Well, why does it have internet community? Well, you know, it's kind of chicken and egg thing. The reason we have chicken and egg thing is because unlike the past conflict, like say World War II, you didn't have TikTok videos of the war. So in other words, right now, the reason the internet, so let's say why internet community involved in war intelligence, in wartime, in military, in quote unquote military, in wartime intelligence. Why? Well, it's very simple, because information came in internet, came on internet, right? So in the past, you have surveillance, military surveillance, take picture of the combat scene. Now you have, say, let's say Ukrainian, okay, Ukrainian fighter, TikTok, okay, with picture of destroy. So Russian fact, he say 72. Okay. Now, is this picture fake, real? Where? How many tanks destroy? Okay. That's what we're talking about today. Okay. Now, you may not be that into it, but this is actually what's happening. This is what's happening to the internet, to the society. So this is a case study, and in fact, this is. I want you to be able to discuss this like in essay form, an exam or whatever. The social construct co-evolve. How will socially involve with this? So the internet, okay, e.g. Ukrainian crisis, conflict, crisis going on right now. Okay, that's what's happening. So the way I want you to be able to tell the story is to, well, the story happens on the internet, so we can find it on the internet. But I don't mean YouTube. I don't mean YouTube internet. I mean intelligence platform. And the most important intelligence platform right now is what's called OSINT. Okay, so this is the, in a way, this is the technology. So the technology number 4, technology we're going to discuss today. Okay, so how about OSINT? Okay, what is OSINT? OSINT is a platform that most of you probably didn't know about. Okay, so it's not just OSINT, it's plenty other things. Okay, so the theme today is online intelligence. Okay? So again, resource, I'm going to give this as a resource. Okay. 2 things I'm going to talk about. 1, satellite imagery or satellite imaging. Okay, the other one is intelligence. And so with intelligence, we talk about OSINT framework. So let's just put this on up on the screen. Okay, OSINT framework originally, I think, didn't deal much with war security. It dealt a lot with internet security. So this is a framework. It's sort of like a community of algorithm and user. It's sort of like information exchange, or sort of like a warehouse, or where people can. It's like GitHub, but not for just Python code or MATLAB or Mathematica code, but it's sort of like a GitHub for intelligence related information. Okay, so this would be something like, if you talk about tools that people use to do phishing and how to do anti-phishing, social network, LinkedIn, Facebook, what do you deal with that? Dating site, what's the dating site got to do? Okay, so all these things are kind of like on the database. Public record, okay, congressional disclosure, death record, all kind of stuff. So these are all sort of like intelligence. So you can think of it firstly as a data source, but it's more than that. It's an entire community. Okay, and one of the interesting one, although this one has very little, is global terrorism database. Okay, dark web, all this. Okay, now so this is one thing. So this gives you all the kind of tools that search threat intelligence, right? All kind of stuff. Okay, so this is sort of like a rabbit hole for data scientists. Okay, but I said not YouTube, but for the purpose of explanation, let's go to YouTube. OSINT Ukraine. So basically what's happening is that this OSINT community, okay, sort of like online internet sleuth, okay, so OSINT is like a rabbit hole for internet sleuth that I don't need this anymore. I don't need this anymore. Okay. This OSINT framework or OSINT framework is also a network. Hold on, give me a minute. Okay, there. Okay. So the OSINT framework would be network of people accessing satellite imaging and blah, blah, blah. So this guy, for example, there'd be like a blog. So it could be a blog. Say, let's say a blog. Say, okay. So with the ongoing Ukraine conflict crisis, okay, OSINT blocker have been verifying TikTok war video for accuracy or for whatever, etc. Okay, they have also been monitoring Gulf, say Black Sea traffic, etc. Okay, all kinds of stuff. So this is happening. This is what's used in real time, and this has been done, you know, many times before. So for example, you can look at picture of I think there's an example here somewhere where you have a picture of the Myanmar conflict when the government, you know, bombs village or something like that. You take a picture and you say, well, it's, where can you find it? All you know is that you have a terrain picture of bombs and village, and this is where internet sleuth comes in, compiling, superimposing this with Google Maps. They can literally pinpoint the exact village where the bomb drops, for example. So and that's what's been happening in Ukraine as well. So you can take a city like Mariupol. So if you think about it, you can wait. Okay, you can wait for the news agency, say the news agency, to track it. Okay, so let's say this is New York Times, right? So New York Times does this, and this is nice. This is very nice for you as a consumer, right? You can literally do this. You can read, okay? But this is actually secondhand information. This is already been compiled. This has already been drawn in a very nice infographic, you know, where's the attack. So this is, say, Mariupol. This is where buildings are bombed and so forth. So New York Times did this for you. But New York Times didn't do this themselves. They actually compiled this basically from a bunch of OSINT network user who would, so let's go to maybe something more. Okay, so these are the OSINT people who have created all this map, okay, before superimposing the map with satellite image, okay, with and you will see that later on it's more than that. It's not just looking at picture, right? It's not looking at picture. There's actually a way of superimposing this with AI. So I think there is the website that I want to show you. You can watch it on your own, by the way. This is again, this is I think this. Okay, I think this. What the OSINT people did was actually have a satellite image. Okay, so let's go to here. Let's go to here. Right here. This is what's called Gulf of so Ukraine map. Where's Ukraine map? Yeah. So okay, right. Now everybody's seen this picture, right? This is the Black Sea. Well, here, locked in here is a little bit of Sea of Azov. This is a little bit under Russian control because Russian annexed Crimea in 2014. So they control this. So all this, you can assume, is Russian control. So what they actually could do is take a satellite image of this area. Satellite image of this area, okay? Which is, again, the technology you have. put in an AI that does sort of like object detection and literally counts ship, presumably warship, that's happening. So you can apply AI on a satellite image of this, and then look at, you know, where are the ships? Are the ships here? Or look at the ship ready to attack Odessa. So you have all this. Okay, you have all this. Now, this is not just done by the military intelligence, but presumably military intelligence people do that. But the amazing thing that I want to talk about is what's happening inland, because you can have various conflict going on and little battle here. You know, somebody takes a picture of a Russian tank getting hit by a Ukrainian missile, and you want to verify that this is a real picture. This is not an old picture that's taken here and then used to boost morale here, even though that's not necessarily a bad thing. But you certainly want to defog the fog of war. So you take the picture, you actually superimpose it with the map of the known structure, known terrain, and blah, blah, blah. And a lot of time you can do something even simpler. In fact, if you actually have the digital file, you can, now when you take picture, there's like a metadata that comes with the picture. So you can reverse the location of when that picture was taken, okay? But if you don't have that, you just have an image of it, okay, that you cannot, that doesn't have the, does not reveal the metadata, you can sort of like find out where the data is, count the tanks and so forth. So that's really what's happening here, okay? And it's using what's this using? A lot of it is using satellite imaging, okay? Well, what satellite imaging is taking picture, right? When you take picture, what happened is the sun hits the surface, okay? So the sun is a visible of electromagnetic wave, hit the surface, bounce off to the sky, and then passively cameras take picture of it. So camera is a passive thing. So camera is taking the light from the sun that's bounced off of object. Well, what happened when there's when there's cloud covering? Well, visual spectrum doesn't go through cloud, okay? It doesn't go to human body. That's why you need X-ray. But things like X-ray, microwave, this thing goes through cloud, goes through human bodies. Okay. So instead of taking satellite imaging from satellite picture, like taking photo, one of the older technology that's become more active is called synthetic aperture radar. I'm not going to go into a detail because we really don't have that much time, but this technology kind of evolved with World War II, and it kind of matured after World War II ended, okay? And this has been used in many things. So you can see that, okay? So take 4 OSIN plus synthetic aperture radar plus blah, 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 okay? So I'm a whole bunch of things. So for example, SAR, synthetic aperture radar. Basically, what happened is that radar from satellite takes picture in microwave spectrum, so penetrate cloud. Yeah, so that's good, right? Because when you take a Google Earth, say you want to go to Google Earth and then just say, what does Ukraine look like right now? Google Earth, right? So by the way, I download Google Earth Pro. So whenever there's a cloud coverage, right? Whenever there's a cloud coverage, you can't see. Well, this thing you can, okay? This thing you can. So you can't see it from Google Earth, but what you can see is from satellite imaging of other form. In particular, there's this thing called Earth observatory data. So let me go to resource there. So instead of going to Google Earth, which is only going to allow you to watch things in pre-recorded satellite image of visual spectrum, and if it's cloudy day, you can't see it. You can literally go to this, and Earth data has data in so many different spectrum. In microwave, you can see through cloud. So here, there's a picture of Mariupol after the crisis on a cloudy day. Okay, so I'm not going to go into that right now, but certainly you can do that. Okay, so you can literally do this. Now, the reason it's called synthetic aperture is that if you take one picture from just one spot, you don't get high resolution. You need a big camera. Well, they can do synthetic big camera by having satellite take picture here, and then a few seconds take another picture, then a few seconds take another picture, because satellite travels very fast. So in a few seconds, it's just going another 2, 3, maybe 10 kilometers. So it's taking many pictures from many perspectives, and all those together simulates what's called a big aperture. It's as if you have a giant lens. It's not a giant lens; it's a tiny lens on a satellite, but that satellite travels thousands of miles, right? So by taking different pictures every few seconds or so, I don't know how many seconds or how many microseconds or how many minutes, you can get a composite picture of very fine resolution. That's called synthetic aperture radar. So that's okay. So that's you have this, okay, and all kinds of stuff, right? All kinds of stuff. So this thing, by the way, is not just used for war. I don't know. I think some of you are going to sustainability track. Sustainability, okay. Sustainability challenge people, right? Sustainability monitoring via satellite. So, for example, you can say vegetation, deforestation, mangrove, biomass. Okay, so all this is done usually not just via satellite, especially SAR. Okay, there's also this thing called LiDAR, but LiDAR is a bit more local. LiDAR is you take a drone. Okay, so that's sort of like from a drone. So I put that. So okay, SAR. Or drone LiDAR. Airplane, drones, whatever. Okay. And again, LiDAR uses radar. So it's the good thing about radar is that it uses any kind of spectrum. So for LiDAR, they might not use microwave spectrum. They can use infrared to measure heat. Okay. So in fact, satellite can take picture in any other, in most non-visual spectrum. Okay, so it depends on what you want to use, right? If you want to penetrate clouds, you use microwave. If you want to measure heat, you use infrared, blah blah blah. Okay, so and that gives you different information. So there would be some website again, and this I'll give this to you as a resource. For example, I think hold on. Oops. This is very good. So let's go to this platform. I want to show you early. It's very good. It's oops. Oh, it's in the resource, isn't it? Sorry, my bad. Okay. Yeah, Earth cubes, all this Earth cubes. Okay, so this is all the visualization. You can get all kind of stuff in here. You can go to this one as well. Okay, now what I'm trying to say is here. So you have this, right? So you have this. So in fact, not just war, but definitely not just war, because sustainability monitor for this usage. Okay, this is actually a real use case. Okay, it actually came. It's been going on for since the 70s. I think remote sensing. Okay, in fact, there's a special effort by the UN to do that. So all this is done. All this is done. Okay, so you have all this technology. What I mean is underlying all this is ability to identify, locate, position, ability to keep information or organize information system, maybe do some computation on it, like algorithm. Okay, ability to actually take imaging from satellite in various frequency, in various spectrum. Okay, so Google Earth is a pretty thing because it's visual, right? It's visible spectrum. But for scientific, right? For scientific, for sustainability challenge track that I think some of you are going to, that's going to require knowledge, not in visible spectrum, but in infrared, like measuring heat. Sometimes you have different things that detect moisture, right? So various spectrum are very good at picking up different information set. So just as when you go to Google Earth, when you go to Google Map, right? You have Google Map, right? And then when you superimpose Google Map with picture, that is just one level. You can, in all this data set, you can superimpose not with visible spectrum, but maybe I want to say, the temperature of this thing, okay? Temperature in this area, the wind, okay? In fact, I think, there's actually there's one that not only gives you the picture, but gives you actual wind speed going on right now. It's a very live thing. So I should have turned this on before. Okay. So anyway, the point is I want you to explore here all this. Okay, this is going to be given to you today. Okay, all this I've made quite a bit of it, so I think not all of you will be focusing on the same one. Okay, your homework would be to go through this. Okay, basically, forget this one. This is sort of like a fake. Yeah. So all this between synthetic here. Okay, the one that I have expanded. You don't need Bitcoin anymore, right? So here, cyber attacks. So OSINT framework is a general framework. There's one that's focused on terrorism. Actually, there's Deep South Watch, which used to be very active when we had the conflict in the southern part of Thailand. Okay, go through that. There's cyber threat. There's real-time map. This is also very good. So what all this has in common is it's information, layers and layers and layers of information. So the whole thing is layers upon layers of historical live information superimposed on Earth. Simple like that. That's basically it. That's what we're talking about. Okay, so some of it historical, so you can actually look at deforestation. I think there's one that's sort of that's very good. I think yeah, I can show you this one as well. Teaching material way back. Yeah, all this location, and then way back as it happens. Okay, well there are some in here. I am not hiding in okay. There's some here that are actually information about deforestation. Well, it's not. It's just a visualization of deforestation, because you can look at exact same picture of the same location 100 years ago when there was a picture. Okay, not 2,000 years ago. Now, what you can do is, because now you have GIS, right? So you can actually do this. You can do calculation. So this is not photographic picture, but this is calculation. So you can say, I'm looking for, okay, so this is what actually, by the way, this is seawater. So if you zoom in, Bangkok, right? This is where we are. So actually we'll be under the water in 2050. Yeah, that's it. That's pretty much what this thing tells you. Okay, that's what this thing tells you. Where are we? Okay, so Bangkok, all this, where's, sorry, this is where we are. กรุงเทพมหานครห้วยขวางดินแดงสวนเบญจกิติ okay, วัดหัวลำโพง that's closer. So this is จุฬาลงกรณ์มหาวิทยาลัย, right? So it doesn't look so bad. Okay, right now 2030, so that's a few years time. This thing will be underwater. I don't mean underwater literally, I mean level of seawater. Okay, this is the level of seawater rise. So obviously, you know, Netherlands has been living under the water for a long time because they have a dam. So this is not saying that there's going to be water up to here, but this is to say this is where the sea level is. Okay, so unless we have some kind of dam, okay, this is a natural level of water in 2030. Okay, by the time we get to 2050, I think that's just about peak. Everything here will be the same level as the seawater. Yeah, the same level of seawater. Yeah. So obviously we have to do what the Dutch did, which is basically invest in some kind of dam, in some kind of barricade levee. Okay, so this, okay, Google Earth is simple, right? Picture Earth, NASA, picture, but in many spectrum. Coastal climate, picture, calculation. Ocean framework, that's sort of like a hodgepodge of everything. This is the thing about terrorism data map. Okay, cyber attack. Okay, this one I started, but I haven't shown you. This is also another thing that's layers upon layers, that's built on top of the map of the Earth. So this is live, but this is what's going on right now. This is what's going on right now in attack. Okay, each of this line is a line of cyber attack, attempted cyber attack. I don't know, some of this got through. Okay, you can view it flat. So Thailand, this is a different type of attack. Okay, so you know, DDS, that's denial of service. That's easy. Well, not easy, but that's straightforward to understand. So this is actually going on right now. So there's a lot. When I did this a few years ago, there's a lot of North Korean activities. Okay, today, yeah, some Thailand. So this is all cyber attack. This is all cyber attack going between, you know, Brazil and the United States. This is live, by the way. This is okay. So you can view this as a globe. So that's, you know, prettier but not more informative. So that's what's happening right now. Okay. Oh, we are pretty peaceful right now. That's good. But there's some attacking, okay, to and from. So this is going on right now. So that's a cyber threat, right? This is also the same thing. I think these are all the same thing. So go through. I'm going to keep expanding. Keep the map. The map. The mind map expanded like this. Okay. So go through this, and then make a one-page report on you know what, well, not what's your favorite, but sort of like what you find from digging in this. Okay. Hopefully it won't be the same. So maybe what you can do is say, I'm gonna take this, I'm gonna take this like before. Okay, there are only 10 of you, right? So it shouldn't have the same thing. This thing is the you know, synthetic aperture radar technology. Again, this is something that's active, mature soon after World War II, but now it's available to everyone. Okay, so basically, if you go to like NASA site and all this, right, you can see. So all this I put them in separate places. This is resource, meaning that you get information from them. This is a topic knowledge about the synthetic aperture radar. This is about what people are doing. Okay, this is what people are doing. Okay, and this basically is this story here. This story. How will society evolve with this technology? You have this internet sleuth, right? Okay, so obviously internet sleuth can be used to solve crime, but certainly right now the focus is on the war that's going on. Okay, so we talked about this last time. So okay, and the technology here, right? So what can do? Whole world of remote sensing application, and especially for sustainability challenge. Sustainability, wise sustainability challenges. For sustainably monitoring. Okay. Right. Sustainability challenges, or well, basically climate change. Okay. Especially that's a very big area. So this here, I think a few of you are dedicated to the sustainability challenge track for BATSAI. So definitely in your 4 years, remote sensing is going to be your friend. Okay. Remember, I told you that you're going to need like Mathematica as a sort of like a conceptual prototyping tool. Well, for actual data, chances are if you're working sustainability challenges, you're going to deal with remote sensing. And when I say remote sensing, globally, invariably that comes to satellite imaging, but locally, you can say you can monitor soil moisture using drone. So that'd be like using a very local information. So remote doesn't mean, you know, satellite necessarily. Drone is considered remote sensing. So this is also, you know, I could have started this lecture as remote sensing being the technology, but I think I frame it under this kind of internet sleuthing. I think it makes more sense given what's going on in Ukraine. Okay, so I'm going to leave this unpacked. Okay. Okay. Okay, 563 notes. This is how I keep track of how many notes you got. And then you can go through this. So your homework for next week would be this. Now let me finish by asking you to prepare. Now you're going to have to be ready to do your term project, basically, right? Because first of all, there's only 10 of you, so we're not going to have like a group project. So the term project that you hand in at the end of the term, you should have a very fairly solid idea of what you wanted to do. Next week or maybe the week after, I look at the schedule. I think I have invited lecturers, so we'll see how that works. You will present 5 minutes of your term project. I don't mean finished, what you want to do. So there's like a 5 minutes of what you want to do. And then toward the end of the term, before the final exam, there'll be like a 5 or 10 minutes of what it. Okay, so this is like a project pitching or project idea. And I want you to do it in a way that is a little bit open. Okay, so something like, I'm interested in applying emerging technologies to solve sustainability challenge. Okay, and I'm really concerned about the health of the mangrove forest in Thailand. So I'm thinking about the project that would use satellite image, okay, of various spectrum that takes picture of the coastal area. Now, if you have a fine high resolution NASA picture of a mangrove in Thailand, that'd be great. But let's say you don't. Let's say for some reason it's not available, but you have a lot of mangrove picture in Florida. Okay, you can do that, right? It doesn't have to be Thailand. Okay, after all, this is just a term project. Now, obviously, when in your senior project, in your capstone project, which I'll talk about a little bit on Friday, tomorrow, about capstone project in your senior year, certainly it's probably going to be something that hits closer to home. Okay, be like a mangrove for Thailand. But in this term project, do wherever focus your project on problems or data set that's available. So if there's a lot of mangrove picture in I don't know, Belize or whatever, use that. Doesn't have to be Thailand, right? So I want to do that to satellite picture and look at what we know. What can it tell us? It can tell us about what? Progression. Do we have less mangrove now than 10 years ago? Okay. What's going to happen to the mangrove when the ocean become acidified? There's also like calculation that does that as well, calculating or projecting acidity in the ocean going forward. All this can be packaged in your project. Now, next week, or again, might be the week after, when you discuss this 5 minutes, you should also be open to your friend's idea, right? So your idea can say, well, why moisture? Why not check also the sort of acidification, eutrophication? You know what eutrophication is, right? That's when the water runoff from the chemical run into the ocean and gives it a lot more nutrient than is usual. You get algae bloom, and it's not a good thing because it suffocates the fish or something like that. Okay, so all this can be done. All this proposal is really up to you. It really is up to you. And I want your friends. So I don't want one guy to present 5 minutes and that's it. And great. That's not my point. The point is your friends should have an input. So everybody should take turn, not harassing, but like asking critical question of what this project's going to do. What kind of data set? Where's it going to lead? If we have the conclusion, what kind of finding are we going to get? Okay. Let me get another screenshot. Okay, Cap. So that's it. I think I guess that covers it for today. Again, your homework is to go individually, pick from the mind map that I'm going to send in a few minutes. Okay. So look at that and take your area. So this is the area you want to cover and write a 1 page on it. Okay. And then prepare for 5 minutes. So 2 things, right? 1 pager on digging into this internet resource, going into this, how to extract information, how to just look at a picture and find out where it was taken, that sort of thing. All kind of internet sleuthing thing that's being done. Okay. I mean, in Thailand, we have this example, right, where people were looking at the camera. I think it was sort of like a security cam on the recent drowning or something in Chao Phraya River, right? People were contributing like CCTV imaging, right? Well, you can imagine that if you have that and you apply AI on it to enhance this, enhance the the resolution, or you can actually infer what's happening on the boat, because AI can detect motion and then sort of like extract a stick figure action, right? So if you have a video, an AI engine can look at the video and say, what is this person doing? Is this person doing this or doing this, or is person, you know? So you can presumably apply that onto a video and say, oh, this person is pushed off the building, or this person just fell off the building by himself or by herself, and the other person is trying to reach out to grab, right? So all this can be done with the help of AI motion extraction. Okay, but that's a little bit beyond what you guys know. You have to go to you know, apply digital intelligence for that. Okay, so certainly, right, you have a video, you see one person fall off the boat or fall off the building, and then the other person reach out like this. Well, you can apply AI or, you know, technology to infer, is this person reaching to grab help, or this person is actually the one pushing? Right, pushing and pulling, it's very hard to tell in a video. You can use AI to help, that sort of thing. Okay, so this is becoming very powerful. Now, how much of this is accepted in the judicial? That's another issue. That's about how much the law will grow with technology. Now, in the old days, the law doesn't even allow digital signature. You have to have a physical signature, otherwise it's not valid. Well, the law changes. You have digital signature that's verified. The law accepts it. The Bank of Thailand understands it. The check is considered valid if you sign it digitally, that sort of thing. So the law will also grow with that. Okay, Cap. So with that, I think, okay, we'll run a little bit over time, but we also started late, so sorry about that. Okay, so remember the 2 homework, and I'll see you guys next week. Okay, so I have to run as well. So, okay, Cap. We'll have to edit the video, I think somewhere in the middle. Okay, I'll see you guys, and good luck. Remember, your project, you should have a definite idea, but as you are presenting it, it should be very open to your friends' critical assessment. Okay, that's what. Okay, I'll see you guys next week. สวัสดีครับ